हेलो एंड वेलकम टू flameinstitute.com। हाँ जी, आज हम स्टार्ट करेंगे ग्रुप एलिमेंट्स ऑफ ग्रुप 16। द फर्स्ट क्वेश्चन इज विच वन ऑफ द फॉलोइंग आउटर इलेक्ट्रॉन कॉन्फ़िगरेशन रिप्रेजेंट्स एलिमेंट्स ऑफ ग्रुप 16 6a और halogens? ns2np2, ns2np3, ns2np4, ns2np5. Outer electronic configuration of 6a group is ns2np4. So the right option is third option. The atomic number of sulfur is 16. In the ground state of sulfide ion, the ionic electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3p2, 1s2, 2s2, 2p6, 3s2, 3p4 या 1s2, 2s2, 2p6, 3s2, 3p6 या ये वाला। तो अब इसमें जो सोल्यूशन है दैट इज S-2 जो है, जो हमारा जो सल्फाइड आयन है वो होता है 18E नेगेटिव। सो आंसर इज 1s2, 2s2, 2p6, 3s2, 3p6। सो थर्ड ऑप्शन इज द राइट ऑप्शन। The decreasing tendency to exist in puckered 8-membered ring structure is tendency to exist in puckered 8-membered ring structure decreases from S to PO. So first option is the right option. Which one of the following bonds has the highest bond energy? Because of the high SS bond energy, only S has the high catenation power. So second option is the right option. The increasing thermal stability of the hydrides of group of 16 follows the sequence. The H2TE, H2SC, H2S, H2O increases in thermal stability is due to the increase in stability from H2TE to H2O. So, second option is the right option. The correct order of increasing boiling point is the increasing point is abnormally high from BPT to BP high boiling point, and abnormally high boiling point of water is due to the presence of intermolecular H bonding. So it is that H2S and H2O is greatest from them. So fourth option is the right option. Oxygen is more electronegative than sulfur, but H2S is acidic in aqueous solution while H2O is neutral. This is because H2O bond is weaker than OH bond. HS bond is weaker than OH bond. H2S is a gas at temperature, but H2O is a liquid. Molecular weight of H2S is lesser than that of the H2S. The HS bond is weaker than OH bond. H2S can easily release proton and hence is more acidic. So that's why second option is our right option. TeCl4 is expected to be tetrahedral, square planar, octahedral or trigonal bipyramidal. sp3 hybridization, trigonal bipyramidal with one lone pair, CISA geometry. So this is the square planar. The next is in SF4 sulfur is DsP2 hybridized, sp3 dehybridized, D2sp3 hybridized or sp3 hybridized. The right option is sp4 SF4 is sp3 hybridization, so the second option is the right option. In S8 molecule, the type of hybridization exhibited by sulfur is sp2, sp3, sp or sp3d. We have this kind of S8 molecule, so there is a sp3 hybridization. That's why second option is the right option. In bleaching, action of SO2 is due to reduction, oxidation, hydrolysis, or in acid at its acidic nature. हाँ जी, the SO2 plus 2H2O is giving you H2SO4 plus 2H. So that's इस इक्वेशन में क्या हो रहा है, रिएक्शन में हो रहा है, रिडक्शन हो रही है. सो दैट्स वाई ब्लीचिंग एजेंट ऑफ SO2, ब्लीचिंग एक्शन ऑफ SO2 जो है, दैट इज ड्यू टू द रिडक्शन. सो फर्स्ट ऑप्शन इज द राइट ऑप्शन. Which of the following is used as an oxidizing agent in organic chemistry? SO2, SeO2, TeO2, PoO2. The right option is SeO2 is used as an oxidizing agent in organic reactions. So, second option is the right option. The triple S bond in S8 molecule is, the bond angle is 199.5 degree, 107 degree, 120 degree or 60 degree. Close to tetrahedral angle, so 107 degree. Total number of single covalent bonds present in one acid molecule are 4, 6, 8 and 10. The right option is, this is the acid molecule, at 8 single covalent bonds are there. So, third option is the right option. The correct increasing order of dipole moments of the following is H2Te, H2Sc, H2S, H2O. Dipole moment increases from H2Te to H2O due to the increasing electronegative difference between the hydrogen and 6A group atoms. So, second option is the right option. The halogen showing maximum coordination number of sulfur in SXN halides is F, Br, I or Cl. The right option is F shows maximum of coordination number with S because of its small size. So, first option is the right option. Most stable tetrachloride formed by group 6A elements is SCl4, SeCl4, TeCl4 or OCl4. The right option is stability of tetrahalide increases from SX4 to TeX4. So that's why TeCl4 is the right option. Oxide which acts as a reducing, oxidizing, bleaching agent and a Lewis base is SO2, SO3, CO2 or NO. In SO2, S is a intermediate oxidation state and hence act as a reducing agent, oxidizing agent and it bleaches due to reduction. So, SO2 is the right option. In the molecule having 1 pi, p pi and 2 p d bonds is SO2, SO3, CO2 and 2. हाँ जी, SO3 have the 3s1, 3p3, 3d2. So that means they have only one single pairs are there. So that's why that is form the SO3 form the p pi 1 and 2 d pi bonds. The correct order of electron affinity of 6a elements is OTESES. Low electron affinity of oxygen is due to its small size and interelectronic repulsion. So third option is the right option. Regarding SCl4, the wrong statement is: in SCl4, the hybridization of S in sp3 and shape is distorted trigonal bipyramidal. The product of hydrolysis is H2SO3. It acts both as Lewis base and acid. It is very stable liquid. SCl4 is very unstable liquid. So the right option is fourth. The order of acidic character of dioxides of 6A group elements is SO2 greater than SeO2 is greater than TeO2. Acidic nature of dioxides decreases with increase in metallic nature of element from SO2 to TeO2. So that's why third option is the right option. S2Cl2 is isostructural with H2F2, H2O2, N2O2 or S2O2. Hanji, this is the structure of S2Cl2 that is isostructural with the H2O2. So second option is the right option. Oxygen is always divalent, whereas sulfur can form 2, 4 and 6 bonds. This is because oxygen is more electronegative than sulfur. Sulfur contains d orbitals whereas oxygen does not. Sulfur has larger atomic radius than oxygen. Sulfur is more electronegative than oxygen. The correct option is S contains d orbitals while oxygen does not. So, sulfur contains d orbital whereas oxygen does not. Second option is the right option. The bond angles of the hydrides of group 6A elements decreases as we move down the group. This is because of increase in bond pair repulsion, decreases in bond pair repulsion, decrease in electronegativity of the central atom, या increase in electronegativity of central atom. Decreases in bond angle from H2O to H2PO is due to the decrease in electronegativity of the central atom. So that's why third option is the right option. An oxide of a non-metal has the following properties. It acts both as proton donor as well as proton acceptor. It reacts readily with the basic and acidic oxides. It oxidizes Fe at its boiling point, or it is poor conductor of electricity. What is the right option? The oxide is H2O, SO2, NO2 or CO2. Hanji. It acts both as a proton donor as well as a proton acceptor, that is H2O, giving you H positive and OH negative. So that's why first option is the right option. The correct order of the XOX bond angles are F2O is less than Cl2O is less than Br2O. As F is more electronegative in F2O, bond pairs will be close to F atom and hence bond pair repulsions is minimum. So that's why second option is the right option. If X is a member of a halogen family, the highest stability of is exhibit in oxygen, selenium, beryllium or sulfur. Oxygen forms a stable O2 negative ion because of its small size and high electronegativity. So, oxygen is the correct option. Oxygen exhibits a positive oxidation state when it is combination with Cl, N, F or C. The right option is O2F2 giving you +1, OF2 giving you +2. So, F is the right option. The oxidation number of oxygen in K2O, K2O2 and KO2 respectively are -2, -1, -half, -half, -1, -2, -1, -2, -half or -2, -half or -1. The oxidation numbers of oxygen monoxide is equal to -2, peroxide is equal to -1 and the superoxide is equal to -half. So, first option is the right option. The order of OO bond length or in O3, O2 and H2O2 is H2O2 giving you greater than O2 and greater than O3, and these are the options. H2O2 is greater than O3 is greater than O2. So, bond order is 1, 1.5 and 2. So, second option is the right option. O3 plus C2N2 is used as a rocket fuel. The bonds in C2N2 are 3 sigma 4 pi, 3 sigma 3 pi, 4 sigma 2 pi, 2 sigma 2 pi. N is have a triple bond with the CC triple bond N. So 3 sigma bonds and 4 pi bonds. So that's why first option is the right option. The most stable allotropic form of the sulfur is rhombic, monoclinic, plastic or colloidal. The right option is rhombic. S is most stable allotropic form of S. So first option is the right option. Which one of the following properties is not correct for ozone? It oxidized lead sulfide, it oxidized potassium iodide, it oxidized mercury, and it cannot act as a bleaching agent. O3 cannot act as a dry bleaching agent, so fourth option is the right option. Identify the incorrect statement with respect to ozone. Ozone is formed in the upper atmosphere by the photochemical reaction involving dioxygen. Ozone is more reactive than dioxygen. Ozone is diamagnetic whereas dioxygen is paramagnetic. Ozone protects the Earth's inhabitants by absorbing gamma radiations. The incorrect statement is O3 is called the Earth's protect umbrella. So, last, ozone protects the Earth's inhabitants by absorbing gamma radiation is the right option. The elements oxygen and sulfur are called halogens because their properties resemble with charcoal. Their properties resemble not only with charcoal but also with the halogens. These are ore forming elements. These combine with halogens. OSSETE are ore forming elements. That's why the third option, these are ore forming elements, are the right option. Oxygen does not form OF6 because it has a small size. there is a no d vacant orbitals available, has a high ionization energy, has large size. D, O has no d orbitals and hence cannot show covalency 6. Therefore, there are no vacant d orbitals available. So, second option is the right option. The next question is, which of the following does not provide reason for the anomalous behavior of oxygen from other members of its family? Atomic size of oxygen is smallest among us halogens. Oxygen shows maximum valency of 2. Oxygen has no vacant d orbital, or oxygen exhibits allotropy. The right option is allotropy of O2 is not an abnormal behavior. So, fourth option is the right option. When ozone reacts with phosphorus, the oxidation state of P changes from +3 to +5, +5 to +3, 0 to +3 or 0 to +5. 2P plus 5O3 plus 3H2O giving you 2H3PO4 plus 5O2. So they have the 5 oxidation states. So that changes from 0 to +5. Fourth option is the right option. On heating ozone, its volume decreases to half, become double, increases to 3 by 2 times, or remains unchanged. 3O3 is giving you 3O2. So 2 volumes and this is 3 volumes. So the answer is 2 to 3. That means 1 का क्या हो जाएगा 2 by 3, 3 by 2. ठीक है. So the right option is increases to 3 by 2 times. All the 3 atoms of ozone are used up when it reacts with H2O2, PBS, Ki or SO2. 3SO2 plus O3 is giving you 3SO3. So, SO2 is the correct option. Oleum is H2SO4 plus SO3, H2SO4 plus SO2, H2SO4 plus H2O, H2SO4 plus H2S. H2SO4 plus SO3 is giving you H2S2O7, that is a pyrosulfuric acid. So that's why first option is the right option. That is oleum. When concentrated H2SO4 is added to sugar, it gets charred. During this reaction, H2SO4 act as a or an oxidizing agent, reducing agent, sulfonating agent or dehydrating agent. C12H22O11 on concentrated H2SO4 giving you 12C plus 11H2O, that is a dehydrating agent. So, fourth option is the correct option. Solution of SO2 in water is known as sulfuric acid, sulfurous acid, hydrosulfuric acid or thiosulfuric acid. The correct option is SO2 plus H2O giving you H2SO3. That means sulfurous acid. So, second option is the right option. The acid contain SOOS bond is H2SO5, H2S2O7, H2S2O6 or H2S2O8. The solution is, this is the this is the bond of the H2SOOS bonds. So H2S2O is there, H2S2O8. So fourth option is the right option. O2 2 negative is the symbol of dash ion, oxide, superoxide, peroxide or monoxide? The right option is O22 negative is a peroxide. So third option is the right option. When the lead storage battery is discharged, SO2 is evolved, PbSO4 is consumed, lead is formed, or H2SO4 is consumed. A solution of H2SO4 387 by Bate is used as electrolyte in the lead storage battery, so H2SO4 is consumed. There is no SS bond in H2O4 2 negative, H2O5 2 negative, H2O3 2 negative, H2O7 2 negative. This is the structure of that. So S2O7 2 negative, there is no SS bond. Acid which has a peroxy linkage is sulfurous acid, pyrosulfuric acid, diethonic acid or Carros acid. H2S5 is the structure is that is known as a Carros acid. Which has maximum number of oxo groups? H2SO4, H2SO3, H3PO3, H3PO4. This is a structure, so H3PO4 is the right option that has the maximum number of oxo groups. Hydrolysis of 1 mole of peroxide sulfuric acid produces 2 moles of sulfuric acid, 2 moles of peroxosulfuric acid, as 1 mole of sulfuric acid and 1 mole of peromosulfuric acid, and 1 mole each of sulfuric acid, permoxosulfuric acid and hydrogen peroxide. H2S2O8 is plus H2O giving you H2SO4 plus H2SO5. So 1 mole of sulfuric acid and 1 mole of peroxo monosulfuric acid. So third option is the right option. Which of the following ions does not have SS linkage? That is S2O8 2 negative, S2O6 2 negative, S2O5 2 negative, S2O3 2 negative. S2O8 2 negative does not have SS linkage. This is the structure. So first option is the right option. When sulfur is dissolved in oleum, a deep blue solution containing polyatomic sulfur cation is obtained. The formula for the cation present is S4 2 positive, S8 2 positive, S19 2 positive or S16 2 positive. The right option is SH2 positive. A salt of sulfurous acid is sulfate, sulfuric, sulfite or sulfide. The right option is sulfite. Which of the following is not a disproportion reaction? Reaction with of Cl2 with NaOH solution, reaction of Cl2 water with hypo, reaction of white P phosphorus with the KOH solution, or reaction with S with the NOH solution. The right option is Na2S2O3 plus Cl2 plus H2O giving you Na2SO4 plus 2HCl or S. So, second option, reaction of chlorine Cl2 water with H hypo is the right option. Transition temperature at which rhombic sulfur and monoclinic sulfur are stable: 98 degree, 95 degree, 102 degree, 112 degree or 114.5 degree. The right option is 95 degree. Which of the following has maximum pKa value? That is H2O, H2S, H2Ce or H2Te. Solution is Ka value are increases and pKa value are decreases from H2O to H2Te. So the maximum value of H2O. Which one of the following has bond angle very close to 90 degree? NH3, H2S, H2O or CH4. The correct option is in 6A group hydrides except in H2O. In the remaining hydrides, pure orbitals of 6A group elements are involved in bond formation, so their bond angles are nearly equal to 90 degrees. So H2S is the right option. Thank you. सर हो गया. हाँ जी सर हो गया.
बटन दबाने के 3 सेकंड के बाद बोलना शुरू करते हैं और माउथ के पास ले जाके बोलते हैं.
हाँ जी सर हो गया.
बटन दबाए रखना होता है जब बोलना होता है.
ओके ओके. हेलो.
अपनी बात बोलने के बाद फिर बटन छोड़ देना होता है, तब आपको आवाज आएगी. अब बताओ.
हाँ जी सर हो गया मेरा काम.
ओके. खाना है. खाना है. नहीं खाना अभी. अभी आपने स्टॉप